here to solve, but let's first of all have a recap of some key points. For the first one, we are to find the midpoint M of line segment AB. How do we find it? We add the S coordinates S1 plus S2 divided by 2, comma, add the y coordinates of the endpoints y1 plus y2 divided by 2. This is the midpoint of line segment AB. The next one says we should find the gradient of line PQ. Since line PQ makes 90 degrees, meets the line RT at 90 degrees, we can write gradient of PQ equals minus 1 divided by gradient of RT. The third one, how do you find S? We see that in a diagram in key points 2, the S is the point of intersection of the two lines PQ and RT. So to solve for the coordinates of S, we solve the equations of PQ and RT simultaneously. Solve the equations of these two lines simultaneously. That's to find a point of intersection of two functions. We solve simultaneously. The fourth one says that we should find the area of figure ABC. To find the area, we can make use of the shoelace method. It says half multiply the absolute of. Now you are going to go from point to point, start from, find the area of figure ABC, start from A, move to B, move to C, and come back to A. In coordinate A, the S value is S1. Move to point B, the S value is S2. Move to point C, the S value is S3. Come back to the point A, the S value there is S1. Now write the Y coordinates. So same process, move from A, move to B, then move to C, and move back to A. In A, the Y coordinate is Y1. In B, the Y coordinate is Y2. Next, Y coordinate is Y3. Y coordinate is Y1. So the area of figure ABC is given as this, which can be expressed as half multiply absolute of. Now this is what you do. Multiply all these ones. S1 multiply S2 gives you S1 S2 plus S2 Y3 plus S3 Y1 minus, you are going to subtract the other products, these ones, multiply this, multiply this, multiply this. Take the sum of these products from, subtract the sum of these products from the first bracket. We have it this way. S2Y1 plus S3Y2 plus S1Y3. So now let's go ahead and solve the problem. Solutions to this question by accurate drawing will not be accepted. The diagram shows a quadrilateral ABCD with vertices A, B, C, and D. The angle ADC is 90 degrees. The lines BC and AD are extended to intersect at the point S. The first question says that we should Since given that C is the midpoint, C is the midpoint of BS, find the coordinate of B. Let's make use of the information I've underlined. C is the midpoint of BS. We know that the midpoint, now the midpoint is 10,4. The midpoint is equal to the sum of the S coordinates of the endpoints of the line segment being mentioned. Now the line segment being mentioned is BS. We are told that the point C is at the middle of line segment BS. We don't know the coordinates of S. Let it be A, comma B. So midpoint equals the sum of the S endpoint of the sum of the S coordinate of the endpoint C plus A divided by 2, comma the sum of the Y coordinates minus 4 plus B divided by 2. So all this implies is that 10 is equal to the 10, which is the S coordinate at the left hand side, should be the same as the S coordinate here at the right hand side. Multiplying both sides by 2 to clear the fraction, you are going to get 20 equals 6 plus A, which in turn gives the value of A to be 14. Again, we should have that the Y coordinate 4 at the left hand side equals the Y coordinates at the right hand side. Multiply both sides by 2 to clear the fraction. We are going to get 8 equals minus 4 plus B, which in turn gives 8 plus 4 because B, the value of B is 12. So it tells us that the coordinate of point S in the diagram is A 14, comma B, which is 12. Now, but it doesn't end here. Question says that we should find the coordinate of D. How do we get a coordinate of D? We see that two lines intersect at D. Line AS and line CD intersect at D. So we should be thinking of solving these two lines simultaneously. This calls for finding the equation of line AS and also finding the equation of line DS. Which of these two lines do we begin with? Let's begin with line AS. Find a gradient of line AS and hence the equation. So let's do that. Gradient of line AS because change in Y. Now the value of A is 14, value of B is 12. So change in Y, that is 12 minus 6 divided by change in S, 14 minus 4. That gives 6 out of 18, which in turn is 1 out of 3. Now go ahead and find the equation of line AS. Y minus Y1 equals gradient multiply S minus S1. Multiply each of the three terms by 3 to clear the fraction. I'm going to get 3y minus 36 equals S minus 14. And this gives 3y. Adding 14 to both sides, we are going to get 3y minus 22 equals S. Let this be a first equation. Next, we want to find the equation of line, the other line CD. Line AS and line CD intersect at D. So we solve these two lines simultaneously to find D. How do we find the gradient of line CD? We see that line CD meets AS at 90 degrees. So the gradient of line CD should be equal to -1 divided by gradient of AS, and that gives -3. So equation of line CD, y minus y1. Now pick a point that lies on CD. The point C lies on CD, so we substitute S equals 10, y equals 4 into the general equation of straight line. Y minus y1, that's 4, equals gradient of CD is -3, equals -3 multiply S minus S1. And this simplifies to y equals -3s plus 30, adding 4 to both sides, have it this way, 34. Here's the second equation. Line CD is gotten as this, equation 2. So now solving these two equations simultaneously gives you the coordinates of D. Let's put equation 2 into equation 1. 3y, now the value of y is -3s plus 34. 3y minus 22 equals s. That's -9s plus 102 minus 22 equals s. This gives 102 minus 22 gives you 80. Is that it? Yes, 80. Adding 9s to both sides, we are going to have it this way. Now divide both sides by s, divide both sides by 10. The value of s is 8. Here is equation 3. Next, we substitute equation 3 into equation 2. Now equation 2 is giving us y equals -3s. Now value of s is 8 plus 34. That gives y equals -24 plus 34, which in turn gives 10. It tells us that the coordinate of the point D is 8, 10. We have gotten the coordinate of D as 8, 10. Now the next question says that we should calculate the area of quadrilateral ABCD. We can use the shoelace method to do this. Area of figure ABCD equals half multiply absolute of. Now move from A to B to C to D and come back to A. In A, S coordinate is -4. Move to B, S coordinate is 6. Move to C, S coordinate is 10. Move to D, S coordinate is 8. Move to A, S coordinate -4. Go in the same sense of direction and write the y coordinates. We are going to get 6 here, -4 here, 10 here, and 6 here. The the y coordinate, 6 minus 4, 4, 10, and come back to 6. So next, you are going to write half multiply absolute of into brackets, write down the sum of the downward products. Minus 4 multiply minus 4 gives you 16, plus 6 multiply 4 gives you 24, plus 10 multiply 10 giving you 100, 6 multiply 8 giving you 48, minus, now take the product of the downward, take the product of the upward, take the sum of the upward products. So 6 by 6, 36, plus minus 4 by 10, that's minus 40, plus 4 by 8, that's 32, 10 by minus 4, minus 40. So this gives